In today's lesson, we'll be learning how to solve equations with brackets. In our first example, we want to solve 3 bracket x plus 1 bracket equals 24. First thing we want to do is rewrite the question. Next, we want to simplify the left side of the equation and the right side of the equation. You'll notice that there is a number in front of brackets, which means we're going to be using the distributive property to distribute that number to everything within the brackets using multiplication. Therefore, 3 times x is 3x, and 3 multiplied by positive 1 is a positive 3, and the 24 on the right side of the equation stays exactly the same. We want to solve for x. In other words, we want to isolate x. However, x is not isolated. It is stuck with a multiply by 3 and a plus 3. At this point, we need to do the opposite of BEDMAS, which means we're going to deal with the addition and subtraction before the multiplication and division. To get rid of the plus 3, I'm going to subtract 3 from both sides of the equation. Positive 3 subtract 3 cancels out, which leaves us with just 3x, and 24 subtract 3 is 21. To get rid of the multiply by 3, we need to divide both sides of the equation by 3. The 3's cancel out, which leaves us with just x, and 21 divided by 3 is 7. Therefore, x is equal to 7. In our second example, we want to solve 3 bracket x plus 2 bracket equals negative 9 subtract 2x. The first thing you want to do is rewrite the question. Next, you want to simplify the left side of the equation and the right side of the equation. As you can see, we have a number in front of brackets, which means we have to use the distributive property to distribute that positive 3 to everything in the brackets using multiplication. For 3 times x is 3x, and 3 times positive 2 is positive 6. And everything on the right side of the equation stays exactly the same since they are also unlike terms. We want to solve for x. In other words, we want to isolate x. However, you'll notice that the terms containing x are on both sides of the equation. So that means we're going to have to either collect all of these terms with x on the left side or on the right side. I'm going to bring all of these terms to the left side of the equation. In order to bring negative 2x to the left side of the equation, I'm going to have to add 2x to both sides of the equation. All we need to do now is simplify some of these terms. So 3x plus 2x is 5x, the plus 6 stays the same, negative 9 stays the same, and negative 2x plus 2x cancels out. I want to isolate x. However, x is stuck with a multiply by 5 and a plus 6. Remember, we need to do the opposite of BEDMAS, so we're going to deal with this plus 6 first, which means we're going to subtract 6 from both sides of the equation. That means the plus 6 subtract 6 cancels out, which leaves us with just 5x, and negative 9 subtract 6 is negative 15. Rid of the multiply by 5, we need to divide both sides by 5. These 5's cancel out, and negative 5 divided by 5 is negative 3. For x is equal to negative 3. In our last example, we want to solve and check 3 bracket 4k minus 1 bracket plus 2 bracket 5 minus 3k bracket equals 7k. First thing you want to do is rewrite the question. Next, you want to simplify both the left side and the right side of the equation. Since we have numbers in front of brackets, we need to use the distributive property to distribute that number to everything within the brackets using multiplication. For 3 times 4k is 12k, 3 times negative 1 is negative 3, positive 2 times 5 is positive 10, and positive 2 multiplied by negative 3k is negative 6k. And the 7k on the right side of the equation stays exactly the same. You can see we have some like terms on the left side of the equation. So 12k and negative 6k and negative 3 and positive 10. We need to simplify these first. Group these like terms together. So I have 12k, subtract 6k, and negative 3 and positive 10, and the 7k stays exactly the same. So I have 12k subtract 6k, which is 6k, and negative 3 plus 10, which is just positive 7. Remember, we want to solve for k. We want to isolate k. However, there are terms with k on both sides of the equation. So either we need to move all of these terms to the left or all of these terms to the right. I'm going to move all of the terms with k to the left. So to move the 7k from the right side of the equation to the left side of the equation, we are going to have to subtract 7k from both sides of the equation. Therefore, 6k minus 7k is minus 1k. However, you do not write the 1 in. The plus 7 stays exactly the same. And the 7k subtract 7k cancels out, and it becomes 0. Remember, we want to isolate k. But now k is stuck with a multiply by negative 1 and a plus 7. We need to do the opposite of BEDMAS, so we want to deal with the addition and subtraction before the multiplication and division. Which means to get rid of the plus 7, we have to subtract 7 from both sides of the equation. Therefore, the plus 7 subtract 7 cancels out, which leaves us with just minus k, and 0 subtract 7 is negative 7. K is still stuck with a multiply by negative 1. To get rid of that, we're going to divide both sides by negative 1. So these negative 1's cancel out, which leaves us with just k, and negative 7 divided by negative 1 is positive 7. However, we're not done yet. We need to check to see if k equals 7 is correct, which means we need to do a left side equals right side check. And I'm going to do this with the simplified form of our equation. So the left side is equal to negative k plus 7, and the right side of the equation is equal to 0. I'm going to substitute in k is equal to 7, which means instead of writing the variable of k, I'm going to write 7 in brackets. So negative 7 plus 7 is equal to 0. So as you can see, the left side is equal to the right side. So since the left side is equal to the right side, therefore k equals 7 is correct.